we'll see whether it's light or dark. I'll leave that up to your own interpretation. Okay, so, well, Neil said it all. Intent-based networking is kind of marketing hype. But I wanted to look a bit under the covers, see what it really is, see if it's useful to us. So a little bit about myself, network engineer, automation at 10IT and Ncubed, where I do probably what most of you also do, help people run and automate networks. In my spare time, you can find me riding a bike or hitting people with foam swords. But before I start, I have a slight disclaimer about my code, my DIY solution. First of all, whatever I'm going to show you, it's non-production code. It is based on a real deployment, but it's not actually deployed code. We built something like it for a customer, and then I thought about it a bit more, and this is more like a thought experiment of what I perhaps should have done for that customer, could have done, and it's based on that. Second of all, don't blame me on my tool choices. I've decided to do everything with Ansible just because. If you want to debate Ansible versus Nornir or native Python or any other tool choice, I'll be at the bar. I'd love to debate it, just not now. And for the third disclaimer, I have to tell you a bit about, well, how I work, what my thought process is. So please allow me a little digression. I want you to talk to you about my smoke sensor. A while back, say about 10 years ago, I bought a Nest smoke sensor, which was really nice because it's smart and it has an app, so I can see remotely whether my house is on fire, and it gives it gives me a good feeling that I know that it's still working, that the battery is okay, because I can see it in my app and I can get an alert from my own monitoring system when it's not okay. So that's nice. Until I started to dig a bit more, and then, well, they took away the API, and it's a really expensive piece of kit. And it's 10 years old, so I have to replace it. And, well, there's a new law that says I have to have many more smoke detectors in my house. So I decided to think about it a bit and see, well, what's actually in a smoke detector. And it turns out it's a bunch of sensors, and it's some compute. So, well, I thought about it. Can I do it myself? And sure enough, you can buy compute, and you can buy sensors, and you can buy a nice LED to put it all together. And it's really cheap, but then you have a couple of components, and you have to figure out how to integrate it and then do something useful with it. So I had to learn about a whole bunch of stuff, like what to do with a LED, because you can't just plug it in. And I had to use some low-code stuff and 3D print a case and all the stuff. But it took a lot of time, but it was really fun to learn. And then how to work in smoke detector. Well, I didn't put it in production. I mean, I did put it in production, but I also bought some real smoke detectors because it's safety critical. And I'm not trusting my own soldering skills, just quite yet. So that's how my brain works. And I had about the same thing with intent-based networking. I read about it a lot, I heard about it a lot, and I wanted to know, well, what is it? So let me start by talking to you about IBN. What is it? Well, if you start to look online, you find a lot of marketing materials. And it's really fancy. It's like a smart network that solves all your problems automatically. Basically, the network can run itself. It's magic, which is awesome. And also, I don't think any of us believes it. I don't. Luckily, the IETF is working on, well, what is IBN? And there's a draft, it's actually really close to being a proper RFC right now, about concept and definitions of IBN. That's really helpful. They're defining intent-based networking as a network that can be managed using intent, which, yeah, I guess, not really helping. Luckily, they define intent, and what they're saying is it's a set of operational goals defined in a declarative manner. Okay, operational goals I can handle, declarative manner, I'm thinking Ansible, but it could be anything, that makes sense. Sure, you can do it. All of the marketing slides have something like this picture in it. This is an intent-based networking system, the big blue part, it's IBN system. It takes business logic, which is used to define intent. And from that intent, you can generate configs, deploy to infrastructure, get state from the infrastructure, verify if it still matches your intent, and if not, fix it. That's what the engine, the orchestrator in the middle does. It's the engine that makes sure your network infrastructure, your state, conforms with your intent. And the intent is a translation of business logic. So, like this is my intent for a network. I'd like to have my network conform to this intent. Unfortunately, no intent-based system in the world is going to let you just input this and then it'll magically run your system. Sadly. So this is more like operational goals that you want to achieve. So they are really specific technical stuff that I want to achieve. And the important thing in these is their system-wide policies. So it's never about let device X do Y, but it's about my network should be a leaf-spine fabric. Or make sure the core switch is the SP route. Route. So, domain-wide. Okay. So that sounds doable, right? Do I need a fancy, expensive solution from a vendor? I'd like to see it in production first. Well, I just decided, why not do it myself? At least I can learn something, and if it doesn't work, I will know what are the right questions to ask my vendors, so they can sell me an expensive solution. Okay, what did I build? I started with the leaf-spine fabric. Why? Because every intent-based networking system in the world is probably starting from a leaf-spine fabric. The data center is a very nice packaged system, which you can run in and of itself. You don't have to consider all the external connections. And it's very, very predictable architecture. In fact, one of the leading intent-based networking vendors, Juniper, their Abstract platform just now announced they're allowing topologies different from leaf-spine. And there's a whole list of caveats and requirements that you have to match in order to be able to do that. So that sort of makes sense. Then I've got my intent. These are my leaves and spines, and I have a bunch of configuration, which are all the messy details, which my system should be able to take care of itself. And I have a verification. I'll check whether there are BGP peers. What I don't have is a closed loop. This is on purpose. For demo purposes, I want to see every step in and of itself and be able to do every step in and of itself. So there's still a man in the loop, which is pretty easy to automate, but which I haven't done yet. And I'm using Ansible to do all of it. There's no Python, just purely Ansible, which hinders me somewhat, but it also makes for really clean code. Leaf-spine topology, pretty predictable. That's a nice thing about leaf-spine. It is predictable. You can create an algorithm to calculate loopback addresses, IP addresses on underlay links, etc. I've got a controller running, which is basically just a Linux server running Ansible, and that's it. My happy state, I'll be happy when every spine is paired with every leaf. That's it. So I'll do a show BGP summary and check whether all my states are established, and then it's okay. If BGP is okay, then there's a whole bunch of stuff that needs to be happening on the background, which should also be okay. The cabling should be okay. The interface addressing should be okay. The IGP should be running. So it's a really good check to see whether or not my system is running fine. I've got configuration, Gilijamse templates. If you haven't yet learned about Gilijamse templates, I think you should. It's a templating language. It takes a whole bunch of variables, like interface configuration variables, BGP, AS numbers, etc. You combine it with a template, and then it'll generate configurations. Now, the important thing is all these configuration details, all these variables, they aren't my intent. My intent is to have a leaf spine network, and all the configuration details is just implementation. So I have to figure out a way to get all those variables just from my intent. Intent should be as high level as possible. So on the right, you can see what is really my intent, and basically that's it. I've got a bunch of spines and I've got a bunch of leaves, and I have to figure out a way to make them out of band reachable. And that's it. This is all of my intent. And from here, I should be able to calculate, to generate an entire Ansible inventory. Of course, again, using Gilijamse templates and using Ansible. This will generate all the variables, all the interface IP addressing, AS numbers, all of it, which are then used to generate configuration, push it to my routers using netconf, and then I can verify it, again using Ansible. So I've got 3 Ansible playbooks, 1 to turn my intent into a complete inventory, 1 to turn the inventory into running config on devices, and then finally 1 to grab the state from the devices and compare it to my intent. And that's it. I was kind of afraid that I had much too many slides for my time, but I'm fine, so I can take a little breather and show you the demo. So I'll pause it. Say, yeah, to show you what's happening. It's paused now, right? No, it's not. Now it is. On the left side, you can see my controller running. It's Linux running Ansible. Is this readable? Hardly. It is on my screen. Sorry about it. Okay, so I'll take the time to explain it a bit more. You can see me listing my intent.yaml config file, which has which has 1 spine and 2 leaves. And on the right side here, you can see my router 1 is one of my spines, and router 2 is my other spine. Is it? Yeah, okay, fine. So what I did is I did a show BGP summary on spine 1, and it says it has 2 connected leaves, sessions established. My second spine should not have any BGP sessions because it's not running yet. I did a show config, which is just the bare minimum of config to make it reachable. Yeah. Now, I recorded a demo to make this easy, not hard. And now what I did on the controller is this is my verify intent verification playbook. It just checks the BGP state, and it shows everything is okay, everything is green. Router 1 has BGP connections with both leaves. That's what it's expecting. Now, off screen, I'm changing my intent. It's just a text file, so I'm adding a spine and a leaf, and I'll show it in a second. Is it running? No, it's not. There it is. So I've added a second spine and an additional leaf. Now, when I verify my intent, it'll tell me that everything is wrong because the second spine has no BGP sessions established. Okay, first I'll parse the intent. You can see I have now more variables in my inventory. There are now variables for router 2 and router 5. They're new. Did I miss the verification? Oh, missed the verification, but that's okay. So now I've pushed the config to devices. It has changed every device because I've added a new leaf, so it has to, and a new spine, so it has to add everything. And now when I verify, you'll see that I get a whole bunch of red text because it's expecting BGP sessions between the second spine and all the leaves, and between the first spine and leaf 1, and it's not there because it's taking a while. But through the magic of editing, we don't have to wait a minute for it to establish. And after about a minute, the sessions are established, and when I check, it'll loop back to the end, to the beginning. Then you can see that all the sessions are established, and it's all is green. So that is a very non-impressive exploding demo of a very simple intent-based network system. Yeah, can I go to the next slide? Yeah. So what does my code consist of? It's got a couple of Ansible playbooks, 3 of them, one to parse the intent, turn my very small list of things I want my network to do, having 2 routers and 3 spines, and then generate an inventory. Second, use the inventory to generate configs and push it to the devices. And thirdly, get my BGP state from my devices and verify whether or not all my spines are connected to my leaves. I've got a bunch of inventory templates, which are the templates used to generate my inventory for my intent, and I've got device templates using the inventory to generate device config. The important thing is that the inventory template, so that's the first step, parse intent, that has to contain all the logic. This is basically the translation part, where it takes my business intent, which is run a leaf spine with these spines and these leaves, and then turn it into something my intent engine can use. If you want to check my code, it's there on GitHub. Just have fun with it. So, summarizing this very short talk, I don't think intent-based networking is as magical as it sounds, which is, on one hand, it's good because it's something we can use. On the other hand, it's not something that'll keep me from being paged at 3 a.m. It's very hard to deliver on marketing promises, but I think it does have its uses once you understand it. And cycling back to where it started, about 5 years ago, Gartner coined, well, they didn't coin the term, they popularized the term, And if you look at their hype cycle, I don't know if you've heard of the hype cycle by Gartner, but they're plotting new technologies based on whether it's hype or whether it's production ready, and they're putting it firmly in the bottom of the trough of disillusionment. So it has not lived up to its hype, according to Gartner. And I think that it's still about 10 years until it's really delivering productivity. I think in this case, Gartner is wrong and right. They are wrong because, you can build something intent-based yourself. There's even an RFC about it soon. They are right because the marketing, it's never gonna live up to its marketing hype. So if you want to debate me on tool choices, yeah, do so, I'll be happy. And if you have any questions, I think we've got plenty of time, so.
So Robin, what does the intent-based networking have to do with your smoke detectors now?
Well, the smoke detector story is just showing how my brain works. I really don't like to spend 500 euros for a couple of smoke detectors if I can do it myself. And it's with intent-based networking, it's the same. People try to sell me really fancy systems for a lot of money. It's not my money, I know, but still, I'd like to check first what's in it, and can I do something like it myself?
So your brain is also intent-based. It's
yeah.
Not to spend money on useless stuff.
Yeah. Well, I don't want to say it's useless.
All right.
But I want to know if it's useless or not.
Good. Any other questions for Robin about smoke detectors, intent-based networking, or how his brain works?
Why Ansible again?
Yeah, why Ansible? Because it's easy. Oh, okay. Well, actually, that's a completely different talk, but if nobody else has any questions, I'll jump into it. Ansible is probably the simplest way to get started in network automation because you don't have to actually learn any code. It has its own language, but it's quite easy to learn, and it's quite easy to start doing some useful stuff. So that's why. On the other hand, it has a really long list of limitations. You really will learn to hate YAML. You really, and it is its own language, so you have to learn another language. If you know a little bit of Python already, or a lot of Python already, there are probably better solutions. Ask me about it at the bar.
Perfect. Thank you, Robin.
Thank you. Thank you.
Ja, precies.